guys, it's Mrs. Rona. Here we are in the final part of the investigation. You have already done all three parts, so you went ahead and measured the temperature change of the magnesium sulfate. You went ahead, and that was part one. Part two, where you got the C of the cup to see how good of an insulator it is. And then that part three, which was the addition, because I did not have the anhydrous sodium acetate, you went ahead and dehydrated all the water. Now we're at the final part where you're actually going to go and design an investigation to make the best hand warmer. So when you look at your AP lab write-up, you're going to have a chart. That chart is going to tell you the cost of it, because to design which is right here, to design the hand warmer, you want whichever one of these chemicals to be an exothermic reaction. So you want the temperature to, one, increase, but secondly, you want it to increase. A traditional hand warmer goes up about 20 degrees Celsius. So you're going to want something that's going to go up, but also be cost effective. You're supposed to design your investigation on this one. However, as I'm recording it, I'm going to tell you how we're going to do it. But you are still responsible to go and write out the procedures and everything that needs to go with this lab. So I already have all of them set up. I am going to use my scale to measure one of them, but everything else has been prepped up, so it just goes a lot quicker. So the chemicals that we're going to have lithium chloride right in here. We are going to measure out 5 milliliters of this compound. I've got calcium chloride right here. I have sodium chloride. Yes, this is a real dangerous one. This is the one you put on your French fries. I have ammonium nitrate right in here. I have anhydrous sodium carbonate. So this one is without any water. And then I have my sodium acetate right in here. This is the one that we did from part 3. This is the one that we dehydrated and removed all the water from it. I went ahead and put like a little plastic glove in here just to prevent any moisture from the atmosphere to go and come back in here, because this one likes water. It's going to suck in water. I didn't want that to happen. All right, so what we're going to do is we're going to take our calorimeter cup right here, this coffee cup. I'm going to set it on to my stir and turn that on. I do have my magnetic pill to place it in there. Okay, it's bouncing. I don't want it to bounce. I want it to stir. There we go. So now it's moving. I'm going to go ahead and pour in 45 milliliters of water into my cup. I'm going to take the temperature of my water and record that as my initial temperature of the water. Oops. The temperature of the water is 22.3 degrees Celsius. I'm going to go ahead and get my lithium chloride. That's the first one. It's already been pre-weighed. The mass of this is 5 grams. I'm going to go ahead and pour it into my coffee cup. I'm going to seal it shut as an insulator. And I'm going to get my new temperature. I'm going to record the highest that this temperature goes. Try to do that as quickly and as efficiently as possible. Didn't seem so efficient though, but we're going to make it work. All right, so I can see the thermometer, the temperature is rising up. Right now it's at 25, but it's still going up. We're at 26, 27. As you're watching the thermometer rise, right now you should be thinking, is this an exothermic or an endothermic reaction? How do you know? What is happening to the system and what is happening to the surroundings? Okay, this one's no longer reacting. So this one got up to 29 degrees Celsius. That was for the lithium chloride. chemicals are safe to toss down the sink. I'm going to go ahead and rinse out my magnetic pill and dry it so I can use it for the next part. All right, the next one I'll be using is my calcium chloride. Here he is. I've already pre-measured the water, and I've measured 5 grams of this substance. I'm going to go ahead and place my calorimeter cup in here. It's a different cup, so I don't want to have any cross-contamination in my solutions. I have 45 milliliters of water right in here. Go ahead and pour it into my calorimeter cup. And I'm going to take the temperature of my water. Just so you know, you're curious, this one has a very interesting shape. It kind of almost looks like nerds. Okay, so that's kind of the best way to describe the look of this one. All right, so when I take the temperature of the water, I'm expecting it to be the same as earlier, but you never know. All right, so tossing my thermometer. Slightly above 22, so 22.2 degrees Celsius. That's my initial temperature. I'm going to go ahead and grab my insulator cup, and I'm going to go ahead and pour all of my calcium chloride in here. I'm going to see what happens to the temperature of my water. Seal it shut. We'll take a new temperature. All right, I'm watching this jump up dramatically. Please don't fall. I thought that wouldn't have been good. Huh? Oh, Miss Templeton's here watching you. She's just laughing from a distance. Say hello, Miss Templeton.
Howdy.
All right, for those of you guys who know us from last year, you know she never leaves my side. I can't get rid of her. All right. So this one right here went all the way up to 34 degrees Celsius. That was a nice temperature change. So once again, you should be thinking, is that exothermic, endothermic? Remember, what kind of reaction is this? What are we trying to do? We're trying to make hopefully you're thinking, a hand warmer. Okay, so we want this to go up, but we also want to have efficiency and cost effectiveness. So those are the two key things when making our hand warmer. Go ahead and pour out my calcium chloride. Rinse out my pill. Move on to the next one. Remember, this is the real fancy dancy one. This is the sodium chloride. Even though that this chemical is safe and we put it on our French fries, by no means does that say, hey, let me just eat it right off the bottle. Okay? I don't know if any of you guys were thinking about that, but I'm just kind of giving you a little heads up. Please don't. All right, so here we go. Here comes the magnetic pill in here once again. You turn it off, just get it back into its magnetic spin. Make it happy. Once again, I have my 45 milliliters of water. Pour it in. Here is my fancy dancy sodium chloride that the school probably paid a bunch for it when you can just get it out of a salt packet. Look at this, what it is. If you've never seen salt crystals, there you go. That's what they're looking like. I'm going to get the spatula. I'm going to go ahead and pour in all my salts. Close it up, and I'm going to see my temperature change. All right. So this one is actually dropping temperature. So I know I forgot to tell you to take the temperature of this one, but we're going to go ahead and use the same temperature as we had in the other one, which was 22.2. Right now, this one is now sitting at 21 degrees Celsius. Ooh, it got cooler. So what is this? Is it an endothermic reaction or exothermic reaction? Oh, it's actually dropping more. Woo-hoo-hoo, this is kind of cool. All right. So I am right below that. So it's looking like it's 20.8 degrees Celsius. Okay, so I don't know. If we're trying to design a hand warmer, do you think it's a wise idea to use salt? Okay, that one is completely done. Let's go to my next solution. All right. So my next one I have is sodium acetate. Same procedure. We're going to go ahead and get our cup, place it on here, fix my magnetic stir to make sure it's in line. I do have 45 milliliters of water. I'm going to remember to take the temperature this time, not unlike the other one. But because I got the water off of the same faucet, it should be pretty much the same anyway. But here is my ammonium nitrate, once again, so you can see this chemical bottle. Here is what the crystals look like. Now I'm going to go ahead and take the temperature of the water. Don't forget this time. Squat down eye level. All right, this one is at 22 degrees Celsius. I'm going to go ahead and pour in my ammonium nitrate and see what happens. Get my coffee lid and take my temperature. Ooh, this one's dropping dramatically. It's now sitting at 18, 17, 16. How low can you go? Let's see. Considering that I went camping with my munchkins on that really cold night, the day before it snowed, yep, ammonium nitrate is not what I would want to make my hand warmer with. It was so cold. And this got all the way down to 16.3 degrees Celsius. Ammonium nitrate sounds fancy-dancy. Definitely a no-go for my hand warmer. No can do. All right, so you should be thinking, what kind of reaction is that? All right, next one, sodium carbonate. Here we are. Now, I haven't measured this one out, so I just kind of wanted to use my scale to kind of get it going, just in case. You have forgotten what was the best method to measure it. If I want 5 grams of this substance, I'm going to use my weighing boat to do it. Which, there we are. As soon as I put my weighing boat for my sodium carbonate, Miss Templeton, can you give me a weighing boat, please? Make her work, right? Look, there she is. Say hi, Miss Templeton. All right, so I have my lab assistant.
That's breaking all lab procedures because my hair's not up. I don't have goggles on. That's why I'm way over here.
Yes. All right, so now that I put it on there, you can see that my weighing boat is 2.2 grams. I'm going to go ahead and zero that out. And then I'm going to use a spatula to go ahead and scoop out my sodium carbonate to come up with 5 grams. Remember, when making measurements, if we go too much, don't put the remainder back into the cup. Just go ahead and leave it outside. We don't want to cross-contaminate my compound. All right, I'm sitting at 2.1, 3.0, 3.9, 4.3, don't grab a huge spoonful, 4.8, just a little bit more, 4.9, just a little bit more. Perfect, 5.0. All right, so this is my sodium carbonate. As you can see, as I bring you on over, 5 grams. All right, so back to the experiment. All right, so I'm going to go and take the temperature of my solution, see where it's at. You want to get eye level with a thermometer. Make sure that you're making accurate measurements. Back to my fresh water. You're out of proof. Kind of weird. This one's at, this one right here is at 21 degrees Celsius. I was expecting to be at 22. That's why I was like, let me double check. But yeah, that's what it is. All right. So I'm going to go ahead and grab my sodium carbonate. I'm going to pour it in and put my insulator cups right away. Pour it on in. Cover my system. Take my thermometer. Place it in here and see what's happening. Oh, I got out of groove again. All right, and this one is also rising. Woohoo! This one's also releasing heat. Nice. So right now I'm at 27 degrees Celsius. Is that it? Is that it? It's moving like a snail. Come on. Come on. It just barely passed over 27. So 27.2 degrees Celsius. We'll go ahead and call it. All right, the last one we have is going to be that sodium acetate in the 3 molar. But if you remember, we went ahead and dehydrated the water. And so now, when I look at it, it's just sodium acetate, anhydrous sodium acetate. Okay. Now, this one's going to be a little weird because it wasn't just coming straight out of the bottle like the one before. And that's why it's sitting here. Now, yesterday when we placed the test tube on your scale, if memory strikes me right, it was 18.2. But double check the previous video. I think that it is. Because you would think every test tube has the same exact mass, but it does not. All right. So if I place it here and place it on my scale, the mass of this test tube is 23.4 grams. That's going to be the mass of the test tube and my scale. So that's the mass of those two put together. Okay, so I'm going to go ahead and get my spatula here, and I'm going to scoop it out from my test tube and do the same exact thing. Okay, so I already have my coffee cup set up. I'm going to go ahead and pour my water on in. My 45 milliliters of water. Place my magnetic stirrer in there. Get in the groove. I'm going to go ahead and record a temperature read of my water. This one is 22 degrees Celsius. It's really weird that the other one came out at 21, but okay, 21 it is. All right, so I'm going to go ahead and poke in here and just kind of loosen up my powder, just because when I had dehydrated it, it became very powdery. Okay. So that's just kind of what I'm doing, just kind of mixing it in there. And I'm a tiny bit concerned that I'm going to still have some powder in here, and I may not have it all out, and I may not have accurate measurements. So what I think I'm going to do is ask Ms. Templeton to get me another weighing boat. I'm going to go ahead and clear it out. I'm going to see exactly how much we have, because we won't have exactly 5. And the only reason I know that's because my B-Days did it this morning, and they were about 4.5, somewhere between 4 and 5, but they were not exactly a 5. And if you think about it, we initially started at 8 grams of the sodium acetate. So I already zeroed it out. I'm going to go ahead and pour it over into my weighing dish. Ooh, I got most of it out. Come on. I'm sitting right now at 4 grams, so it's going to be slightly less. So go ahead and account for that when you go ahead and make your measurements and you calculate your delta Y. You know you want to come out wherever you are. There we go. Ooh, not bad, 4.9. So whatever was left, I might have been right at the 5 mark. I'm gonna go ahead and crunch it up because if you increase the surface area, solubility is gonna increase. So I don't want to have this big little lump in here. So I was seeing Professor Dave when it came to the sodium acetate, and he actually went ahead and dehydrated it into like this Pyrex pan. Oops, this is why you wear an apron. This thing just went splashing at me as I'm trying to cut it up. And he dehydrated in this Pyrex bowl in his oven in his kitchen. I was like, I don't really feel like taking chemicals home and do this in my kitchen. So I figured I would just let you all go ahead and do that on the Bunsen burner. Okay, for those of you guys that are face-to-face, gave them the opportunity to kind of use the Bunsen burner. All right, so let me go ahead and toss that in there because I knew I had some splash out of me. Wasn't much because it's still 4.9 grams. Kind of cool because we initially wanted 5, but 4.9 works for me. All right, so I'm going to go ahead and toss it into my calorimeter cup. And let's go ahead and take the temperature. That's not, oh, I think I did, didn't I? Did I say it was 22? All right, let's just double check. All right. All right, so this one is reading actually at 21 degrees Celsius. I'm glad I double checked it just to make sure I'm right. So my initial temperature of the water is 21 degrees Celsius. I'm gonna go ahead and get my anhydrous sodium acetate. I'm gonna go ahead and pour it on over. Take my coffee lid, cover it on up, and then take my heat temperature. And my temperature is also going up on this one. It's at 23, but it's going slow. You can see it. It's like right in the middle between 23 and 24. So this one is at 23.5 degrees Celsius. That's my sodium acetate, my anhydrous. All right, so we went ahead and got the temperature of all 6 compounds already. You have your data. Make sure you design your data table there. Use your cost efficiency to figure out what makes the best hand warmer. Okay, so make sure you're using all your key vocabulary words that you're seeing inside of our notes and within the packet. Got any questions? Let me know. All right, good job, guys. Miss you all.